This conference will now be recorded.
So last class we were just talking about what is a load balancer, but we did not actually do that, right? So today we will do that, and we will kind of show you hands-on how to do the load balancer. It's very simple. And earlier days we used to have a separate people who does all this load balancing and stuff. With they should have some knowledge on networking, so many other things, right? So now everything is gone. Click of a button, you should be able to kind of set up your own load balancer. Okay, let's get started. Actually, there are 4 types of load balancers in AWS, but the predominant ones are 3. The other one is called gateway load balancer, which is basically used for any third-party virtual appliances. If you're using any third-party virtual appliances in your system, so anything you are trying to reach that, it has to come to a security place. It will check for only if the IPs are secured, then it will pass on the traffic to those virtual machines and stuff, right? So that we will not be covering as part of this particular course. That is beyond our course on this one, but there is one. So if you are sitting for a network specialty exam, then you may need to deep dive into gateway load balancing as well. So other than that, we have 3 kinds of managed load balancer. One is classic load balancer, which is an old generation load balancer, and that is getting retired, I think, in August or September. We will see the date. Okay, so classic load balancer supports HTTP, HTTPS, TCP, and UDP. All the protocols it supports. It doesn't kind of segregate whether you are in the application layer or in the network layer, like based on the OSI model. So application load balancer and network load balancer are version 2 new generation load balancers, and application load balancer we call it as ALB, NLB. And to mention, to talk about load balancer in the AWS, we will always refer as ELB, elastic load balancers. These are all elastic load balancers. Okay, so general term for load balancer in AWS is ELB, elastic load balancer. So we have application load balancer, which was released in 2016, and it works on the application layer, or it's called layer 7 load balancer, which works on the application layer, where it uses the HTTP, HTTPS, and WebSocket protocols, and it doesn't use any other protocol. So they have segregated the one that works on the application layer, the one that works on the network layer. So we have a network load balancer. Again, it got released in the next year, and it supports TCP, UDP, and TLS protocols. So it basically works on your layer 4 of your OSI model. There are 7 layers. So 4th layer is the network layer, and whereas your 7th layer is your application layer. So overall, AWS recommends us to use the newer generation, the load balancer, which provides more features than the classic load balancer. You have an option to set up both internal and external load balancer. When we talk about external, that is the exposing it to the public internet. So whenever you try to access, say, abc.com, it will get diverted it will come to the load balancer, and load balancer will load balance your traffic to both the machines that is attached behind your load balancer. When we say private, why do we need to have private? Similar situation you can have when you have multiple databases and your application is trying to talk to database. For resiliency, you are having multiple databases. One database in availability zone 1, zone 2, zone 3. Then what will happen? You wanted to kind of spread the database load, then have an internal private load balancer, which can be accessed by your application, and your application will route the traffic to the load balancer, and load balancer will in turn route the traffic to the available databases, which will serve your purpose, right? So all these load balancers work on the round robin strategy. It's called round robin strategy. So we cannot control the round robin strategy, but that is how it works. So it tries to find out at the best which one is available and which one can perform faster comparing to the other one, right? Suppose there are 10 requests, right? Assume that there are 6 already in instance 1. So when the 7th one comes, it will try to put it to the next one. Okay, so that is what it will try to do. So load balancers work on security group. That's very, very important. So we already deep dived into security group, but still you need to understand how this load balancer work. So we have the users on the left hand side, okay, who always access our application through internet, right? We can only access it through internet. It can be either HTTP or HTTPS, depending upon whether you have your secure site or it's a normal tunnel, right? So from HTTPS or HTTP, they will be able to access your application. So instead of that, they will go and hit this load balancer. This load balancer will forward the traffic to the EC2 machines that are attached to this load balancer. I'm just showing one here. There can be multiple. Okay. So what will happen? You have a security group that is attached to this load balancer that will listen on the traffic only 80 and 443, nothing else. 80 and 443 from source anywhere. Anywhere means on the internet. All the IPs. When we talk about 0.0.0.0/0 means it's all IP over the internet. So this particular security group that we attach to the load balancer always listens for port 80 or 443, only these two ports, nothing else. So users can access this one either through HTTP or HTTPS. If you are putting HTTPS, you have to make sure you install certificate from the certificate manager, and then you need to make your site HTTPS. Okay. And then behind the scene, once the traffic is here in the load balancer, since now it is inside your AWS network, you need not worry that it can be its normal HTTP without encryption. So you can send it to the private EC2 machines behind the load balancer, and nobody can access this. The user cannot access this EC2 machine even though he knows the public IP and he is having the our key, right? Whatever key pair that he has, even if he has that key, he cannot do that. That is because when we are setting up the security group in this EC2, we have to set it in such a way that we receive the traffic from HTTP from load balancer's security group. So only if the traffic comes through this load balancer, then it has to allow. Other than wherever that the traffic comes other than the security group, everything will be denied. Okay, so that is how nobody can access our resources directly. They can only access through load balancer. Let's take example of Google, right? So when we try to hit Google on our browser, what happens basically? It doesn't go to the Google's pages wherever that it's hosted, right? It doesn't go directly there. It will go to their load balancer. Their load balancer will listen only on 80, and of course Google is 443. So 80 or 443 HTTP or HTTPS, it will listen only on that. So nobody, and then only your load balancer will route our traffic to the servers where the Google pages are hosted, but we cannot access those servers directly, even though you know the IP. If your IP is say 1.2.3.4 for this EC2 machine, you cannot access, even though you have it is public, even though it's you have a key pair, you cannot do because of this particular rule. So that is how you can restrict. The advantage of doing this is, if this machine goes down and you want to add another machine, right? So if the users are trying to access your machine directly, this IP will change. We already saw that, right? Even if you stop and start, the IP will change. Then what you will do? You don't know who are the users are, right? So this will never change. The DNS name will never change. Whether you attach one machine or 10 machines, it doesn't matter. The traffic will come here and it will just forward to all the healthy instances that are attached to this load balancer. So this is how it works, and it's very, very important for your exam and for your interview. This question will be there. Okay, so how the traffic will be coming from load balancer to this one. So some of the things that you need to know: load balancers can scale. They can scale, but not instantaneously, right? I mean, suppose if I'm having a load balancer in region 1 now, and suddenly want to bring another one and do this one, it will take some time for warm up. So you need to contact AWS to bring it up quickly. Okay. Some of the troubleshooting steps when you get 4 XX errors, right? 400, 404, all the 4 XX errors are client induced errors. So that is something which say 404, page not found. Maybe your application server is down, right? Or so your server is not running. So it is 404, you get page not found example. That's a famous number, right? 404. Then we have 5 XX errors or application induced errors. Okay, client induced error, maybe your network is not good, everything will be under 400, 4XX, right? And 5XX errors are application induced errors. Load balancer error 503 means at capacity, either your load balancer has reached the capacity or there is no registered target behind the load balancer. So for both of the things, it will throw 503, and you will need to go and check whether the capacity is there or all the targets are healthy and everything is there, right? You need to go and check. If the load balancer cannot connect to your application, the first thing, suppose if your load balancer, if the users are not able to connect to your application here, then you have to check the security group of your load balancer and make sure appropriate permissions are given to the security group. Monitoring ELB, Elastic Load Balancer, access logs will log all the access requests, so you can debug per request. So whenever the user is trying to access something, everything will be logged here. CloudWatch is a service with a monitoring service, a logging and monitoring service. We will see this separately. We will deep dive into this service. But just to let you know, CloudWatch metrics will give you an aggregate statistics like how much connection count and all those things, right? So you can see this will, by default, there is a default metrics. All these metrics will get into the CloudWatch, and you can use those metrics to write some event-driven architecture. Like say, for example, when I say my connection count exceeds 100, right? Then you bring up another machine, something like that you can do. And you can integrate this with the auto scaling group or auto scaling policies as well. Okay. Any questions here, guys, before we move to the different types and we start seeing that? Okay, so let's talk about classic load balancer, which is a generation 1 load balancer, and your AWS recommends not to use this because they are going to get rid of this year. I think it is August or September. We'll go and see the date, but I think this year it's going to go off. So nobody is, it is not advised to use this classic load balancer. But just for the examination, you may get some questions on classic load balancer, but you just need to know. So it supports both layer 4 and layer 7. So it works on both layer 4 and layer 7 of your OSI model. Layer 4 is your TCP network layer, and layer 7 is your application layer. So that means before they invented this application load balancer, so this was doing all the work. That's all. Health checks are, they had some health check because what happens, there is a health check for your classic all the load balancers, and load balancers will check the health of this machine. Only if the machine is deemed healthy, then it will pass the traffic to that particular EC2. One question in your exam will always be, what will happen if I have two systems and one system is not healthy? What will happen to the traffic that is coming to the load balancer? The load balance, please keep in mind, the load balancer will not forward any traffic to unhealthy instances. It will divert the traffic, or it will flow the traffic only to the healthy instances. So please keep that in mind, very, very clear. Okay. Don't just simply think we are touching 10 machines here, it will put all the 10. All 10 needs to be healthy. Okay, so we will define our own health checks, and we will see how to do the health check, and we will mimic that one of the server is down and how this traffic is getting diverted. So always the traffic from load balancer will only go to the healthy instances, and this particular routing happens only on the health checks. So health checks are either TCP or HTTP based, and once you create a load balancer, it can be any type of load balancer, you will get a DNS name. This name will not change. There is no IP. Okay, there is only DNS name. So this is the name that you need to give it to your customer, or you want to map to your company's websites like abc.com is equal to this load balancer. You can go map that. Okay, there is a service, separate service called Route 53, which is a domain name server. We can use that to go and map our domain with this particular DNS names. So this DNS name is just a name, there is not an IP. Okay, this will never change unless you delete this load balancer. This will never change. So you just have to only map this. And suppose even if you delete and create a one, just go to your DNS server and change this value. That's all. You don't have to worry about what public IP is there behind this EC2. Okay, so this can keep on changing, right? We can go and destroy, we can stop, start, everything will happen. So this is just a classic load balancer, so we are not going to see this, but just know that the client, it will listen on the client for HTTP or HTTPS. As soon as the traffic comes, it will just forward to, nothing else it will do. Okay, it will just forward the packets to the network and the traffic patterns to your EC2. There are no many features, nothing in the classic load balancer. It will just get the traffic and flow into your EC2s, that are number of EC2s that are attached behind the CLB, and if they are healthy, it will go and just forward the traffic. Nothing else we had. So this caused a lot of issues when we started moving from monolithic to microservices applications, and we have a lot of Docker containers, right? So nowadays the containers like Docker and Kubernetes are getting more famous, and all our applications are getting containerized, right? So this particular load balancer was not able to support certain needs of the industry, so they had to come up with application load balancer and network load balancer separately. So application load balancer is a layer 7 load balancer. It specifically works only on the 7th layer of your OSI model. I hope we did see that OSI model. If you need, you can just go and read about it in the Google. But just to let you know, this is your OSI model. Okay, let's just open system, right? Model. So you see, these are all the layers that we have. Actually, if you see this, it's working. Even though we say network layer, it works on the TCP UDP, so it's a layer 4, and this is our layer 7. So this is the layer. Actually 7 layers we have: physical data link layer, network layer, transport layer, session layer, presentation layer, and it's your application layer. So our application load balancer works on the layer 7. Layer 7. Load balancing to multiple HTTP applications across machines. So it's here, if you see, you cannot group these machines. So all the machines that are attached to this classic load balancer should run the same application. Suppose, assume that this is a Google application, right? You have 2 machines. In both the machines, it should be exact replica. So that's why whenever somebody hits Google, it will go to this server or this server. They both get the same result, Google. Now, if you're running one application Google here, one application Yahoo here, somebody tries Google, what will happen? Sometimes they may get Yahoo because it will direct to other machine also. So always please make sure behind the scenes, these EC2 machines should have all the same applications. Whereas here, what we can do, we can group this EC2 because we have different containers or different modules. Say for example, some user is doing a payment, right? So we can run payment service in couple of machines, and you can group them together. Those are all called target groups. And you can divert the traffic to the target group depending upon some conditions. That is where all these new load balancers came in with new features. Load balancing to multiple applications on the same machines, like we have Docker containers, you can do that. As I told you, in the classic one, you need to have the similar application and everything. Here you can have multiple applications grouped together in different EC2s and drive the traffic based on different patterns. So this supports HTTP, HTTP1, HTTP2. These are the versions of HTTP protocol, and it also supports WebSocket. Support redirects, and then very important, it redirects from HTTP to HTTPS. So whenever the user is trying to access it through HTTP, you can still make them to redirect that to HTTPS. You can do that. So application load balancer, there are some routing based policies where you can route your traffic based upon path in the URL. Say for example, if you are having an example.com/users, then make the traffic go to a specific set of machines where the users related modules are running. If you are getting as posts, then send it as posts. If you're getting as payment, send it to a particular group of machines which runs only the payment. So based on the path in the URL, you can do all those traffic routing, right? You can do those routing. The routing can be based on the host name in the URL also. So if you are getting one.example.com, you go to this place, right? If the URL is other.example.com, go to this one. So routing can be based on the host name in the URL. Routing can be based on the query string and headers, right? You can pass headers with the name, with the help of the known headers. Okay, suppose if there are 2 applications that you are running behind your application load balancer, if your user is coming from one application, say application A, then you pass the header from him saying it is application A, or in the header or in the query string, right? Then based on that, you can forward to a particular target group and the application will be served from there. Example like this, right? If you wanted user ID, so when we say query string is always question mark some key value, right? ID equal to 1, 2, 3, order equal to false. That is query string. But please be very careful. Using of query string is kind of your own risk. The reason for that is, if you are using query string, that will get displayed in your address bar, right? It will get displayed in your address bar, and I, as a user, can go and change instead of 1 2 3, I can say 4 5 6. Correct? There is a possibility that I can go and edit that value. So you need to be cautiously using this query string stuff, right? Headers you can use, because headers, the end user cannot set any headers. Okay, so these are all some of the routing. This one. ALB are great fit for microservices and container-based application. We just saw that, like Docker, or Amazon has its own container service called Elastic Container Service. Okay, so you will learn this if you are into more developer and other programs, right? You will learn this. It has a port mapping feature to direct to a dynamic port in ECS. So what happens in Elastic Container Network? Every time you create a task, there will be a dynamic port created. So we don't know, right? Every time if there's a dynamic port, what will happen? You are always listening on 80 or 443, and you want to route the traffic to some particular port, then it's a static port, that is okay. If it is dynamic, I don't know. One time it may come 45, another time it may come 4500, right? I don't know. So you have an option to port map. So whenever my traffic comes on 80, please forward to 4500. So you can do the port mapping for and redirect to a dynamic port. Okay, if you are using ECS, you may get a dynamic port, and this application load balancer will allow you to dynamically change your port or map your port from different port, from some port source port to a different port. Now, if you want to do all these things in a classic load balancer, you may require multiple classic load balancer, and you may need to write so many logics there with your own scripting and program, right? Just to achieve all these things, correct? That is why we have this application load balancer. Now take a look, just see this picture again. Nothing is there here, very simple. You go there, and then that will get diverted. The traffic will be forwarded to whatever machine is attached. Just see here now. So we have something called target group, right? I have two applications which is running user modules here, and the application related to my search or payment is running here. What will happen? The user will come as example.com/user that you will pass when he clicks on the add user, for example, right? It will come to your external load balancer, and then that will take this, and based on your routing path and your rules that you have written, it will divert the traffic to different this one. So assume this is a different application and this is a different application. So based on these routing things, that you can route your traffic to your application load balancer. Okay, so this is how your application load balancer will work. Any questions here, guys? Classic load balancer or application load balancer? Application load balancer is free of charge. Okay, we can use it in free time. And application load, again, please be very careful. This will be for the exam and an interview. You cannot have a static IP for application load balancer. You will only get a DNS name. You will only get a DNS name. So if your customer is asking me, give me the IP, I want to whitelist your application load balancer, that cannot be done. That cannot be done, because AWS keeps changing the static IP of your DNS host name regularly. So if you give that, they cannot do that. That's why we are always provided with only a DNS name which is static. Okay, but we will never have a static IP for application load balancer. Keep this in mind. Okay, most people fail in the interview for this question because they simply say yes, we can go on whitelist. You cannot whitelist this. Okay. Okay. So some of the target groups that we have here, what are the things that can be inside the target group, right? EC2 machines can be inside the target group, and they can be managed by auto scaling group. We will see this, right? So auto scaling means when I have 2 machines now, if the traffic is more, I want another 4, you can automatically add them into your load balancer, so that when your client request comes, it can redirect the traffic to all the 6 machines now, including the 4 new created from auto scaling. Then we have the ECS task managed by ECS itself. So you can also have ECS, your Elastic Container Services, as your target groups. You can have something called Lambda functions. There is a Lambda serverless function, and this is nothing but function as code. So this particular user is a serverless, so it doesn't use any EC2 or something. But wherever you want to run some small functions which can execute within 15 minutes, you can go for Lambda function. We will talk about serverless Lambda function when we come to kind of end of the course, but just think that that can also be part of your target group. Okay. So your request that is coming from, it's translated into JSON event, which is nothing but JavaScript object notation event. And using the JSON, you can invoke your Lambda function. Your Lambda function can read the JSON and do the necessary step and throw the response back to the user. IP addresses. When you're attaching this IP address of these machines, all these IP addresses can be private. You don't have to worry. You don't have to put the public IP. You can just take the private IP and you can attach it to the load balancer. ALB can route to multiple target groups. That's what we saw here. Based upon different paths, you can go and send to this guy, send to this guy, and do all the things, right? Health checks are at the target group level. Now, the health check is not on the separate machine. This has to do the health check on the target group. So if this target group is deemed healthy, then it will send the traffic here inside this particular target group, and it will serve the purpose, and it will make sure that the response is sent back to the user via this load balancer. Okay. Some of the things that you need to know for your application load balancer, you have a fixed host name or DNS name. I told you there is no any static IP. The application servers, the application that is running on this server doesn't see your client IP like 1, 2, 3, 4, 5, 6, 7, 8, right? So if this is the client IP, this application will not see this IP. This IP will get terminated, stopped here itself. If you want your application to know the client IP for some reason, or you want to do some insights analysis and all, then it is your duty to set up the header X forwarded for and X forwarded port on port and forwarded proto for protocol port and your client IP. You need to set this on your page when the client is sending the request, so that it will come here. Though IP will be here, still the IP will be passed on if you pass it through the header. If you don't set this header, the client IP will stop in the ELB. Okay, just keep that in mind. Okay. Very important. What we need to understand is, we will talk about later, that's called SSL termination. SSL termination. So earlier days, what will happen is, even though we had a load balancer is also another machine which will redirect the traffic to multiple machines. Say, for example, we have two machines A and B behind a load balancer machine. When you need HTTPS, you need to install the certificate, right? You need to purchase a certificate and install on all the three machines, including the load balancer, and that is then only then the traffic will be flowing from your customer till the end as a secure channel, right? HTTPS. But in this case, what happens is, you simply have only one certificate that is installed on your load balancer. So your client request comes through HTTPS in a secure way, and it stops here and sends back to your EC2 instance using normal insecure way like HTTP, because it is in private network. So that is called SSL connection termination. It can terminate your connection here and send only your non-encrypted request here. Okay. Now coming back to network load balancer, everything is same. Okay, everything is same except this works on the network layer 4. Okay, layer 4 is your transport layer, so it will work on the transport control protocol and UDP, right? UDP, these two, it will work on these two protocols only. It can handle millions of requests per second. When you want a high performing environment, a high throughput for your applications, then you need to go for network load balancer. The latency is very less, whereas we have 400 milliseconds for ALB application load balancer. It is just under 100 milliseconds, right? So it's very fast. Very important, NLB has, you can assign one static IP per availability zone, and it's suppose assigning, you can assign an elastic IP to that. So this one, if you really wanted a static IP, you have to go for NLB, network load balancer. You have to go for network load balancer. You can get a static IP, and you can use that for whitelisting that specific IP wherever you want to whitelist in your firewall rules of your company or your partner company, right? NLBs are used for extreme performance, okay, where the traffic is not going through the application layer, it goes through the, see, whenever we talk about application layer, it actually happens through the internet. It actually happens through the internet, where at transport layer, all it's private, right? It's very fast. So very important, it is not included as part of our free tier. So if you are using NLB, there is a charge that will be kind of billed. If you are using network load balancer, they will charge you for your network transferring of data over the network and all those things, right? So we will just see. So both are same, nothing different. Only thing, this has a static IP that is very fast. The use case for this is where you need very high throughput and where your application need to be very fast. Okay, it's the same thing, nothing different. See here, we have TCP, there we have HTTP, here we have TCP and UDP. So it will work on the network layer, that's all. So you can send, even though we say TCP, TCP/80 is nothing but your HTTP, right? So that's how you can send this traffic to. Any questions, guys, in these three? Please let me know if you don't understand anything. I can repeat. I'll show you how this works, right? That's very important, right? Let's go and start creating some. So minimum for any load balancer, we need minimum 2 machines, right? So let's go first create machine. And what we are going to do, we don't have any big applications at all. So I'm going to install Apache, and we will have some page, index page, which 2 different colors. So we will know that, okay, this is going to A or B. Actually, it should be same application. In real-time world, it should be same application. But since we are learning now, we wanted to prove that the traffic is getting diverted to 2 different machines. So we will have one text in some color, another text in another color. Okay, so when the traffic goes to machine A, it will be in one color. When it goes to machine B, it will be in another color. So we can be very sure that the load balancer is working. Correct? Okay, let's go to, I have a bootstrapping script. Let me use this bootstrap. I don't want to do manually. So we have a bootstrapping script, which is a shell script, which will kind of install the Apache for me and install all the pages and all those things, right? So that I can just bring up the machine and start accessing my application, because that is the one that we need, right? So this is a script. So this is called the shebang. This is called shebang. If you're already aware of Linux, then you know this is called shebang. So this shebang symbol should be there for the machine to know that it is a shell script. If you don't have this line, it will not know which script is this. Okay. So for shell script, it should be hash, then this exclamation /bin/bash. So the first line is to update all your AMI with the latest patches. Sudo is for root, M is your package manager for Linux. If it is a Ubuntu, then you will have apt get as a package manager, apt-get. Then the next step, I'm installing HTTPD. HTTPD is your Apache. I'm giving -y because what will happen if I don't give this -y, it will download everything and wait for your confirmation. Do you want to continue? Then you have to go and press Y, which we cannot do because we want to run the script automatically. So we are passing -y here. Then the next step is to start your HTTPD service. And when we say enable, when the machine is stopped and started, the service will also be get started. And last, what I'm doing, I'm just putting this text here under where www.html index.html, which will override the default page. It will override the default Apache page, and I will get my own page with blue color, right? So this is the script, nothing else. Okay, don't. It's very simple. So where do we go and give this? I'll show you. Okay, let's go and run 2 machines now. So I'm not going to create all 2 at the same time because I wanted to change the color, right? Otherwise I have to again log in and do it. So let's do EC2A as 1 machine and EC2B as 1 machine. Okay. Make sure appropriate permissions are given to your security group which are attached to this machine. Otherwise this will not allow any traffic. You know that, right? Only the security group controls who can do what in your machine. Key pair, of course, either you need to say proceed without a key pair or you need to give a key pair. Sorry, let me change this to Northern Virginia. Okay. EC2A. My key pair. If you give proceed without key pair, you will not be able to log into that machine later. Okay, so keep that in mind. So always, even if you don't log in also, that is fine, but make sure you just select some key pair. So tomorrow, if in case you want to troubleshoot, you can go and log in. So this is my, I already have a security group which allows all traffic, all port, right? So just to make sure that you're able to kind of complete this. Okay. To add the boot script, the automatic script, go to the advanced details and go to the end of this page. You have user data, right? This is where you need to put your scripts. If it is Windows machine, you need to write scripts in PowerShell. If it is Linux based system or Mac, you need to write in shell script. That is what we have done. Okay. And go ahead and launch this machine now. Let this come up, and we will also go and create another machine. Let that also come up, right? EC2P. So we need minimum 2 machines to show the load balancer.
Chandra, can you share that script in the chat box?
Yeah, I will upload this also for you. Okay, I'll upload it in our drive as well. Whatever I'm showing here or doing will be uploaded. Okay, just like the EBS commands we did, right?
Yeah.
So let me go and select quickly. I hope you guys are already aware what we are doing, right? So we've already done this multiple times. If you still have any doubt, please get in touch with me, then I will try to kind of explain to you. Okay, fine. Now this time what I'm going to do, instead of blue, let me make it as red, right? So visually we can see this machine is running under red. So red is B and blue is A. Of course, all the contents are same, right? Now go back here just to make sure if our application is up and running, select the, since one more thing you need to keep in mind, whenever you give a bootstrapping script in the user data, the more number of lines or more operations you do in the script, the more time it will take for it to initialize. So you need to wait accordingly, okay? Because it has to download, go and come back and do a lot of stuff, right? So the first machine is ready. So we are in blue color, okay? The second machine is running, but still not yet initialized, but still we will go and try to check and see, right? Still not up. Okay, so we will have to wait for a few minutes because we waited because we were creating another machine, so it took some time for it to create them. So once this is up, then we'll go and create our, see now we are actually able to access this application using this public URL. Okay, I want to show you that we will be able to access how, then we have to restrict this, right? So we have to see the both. That is why I just have this open for now. Let it be there. Okay, let's come back to this and see if we are getting your page. It will take some time, just like the other one. What it is basically trying to do, it's basically trying to download all the Apache, install and do all the commands that we have already given there, right? See, now we have A blue and this is red. So whenever a traffic is routed between the two machines, we will know that it is going to two machines. If I have blue in both, you will not know to which machine it is going, right? Because we cannot see the IP also. So this is what, that is why I'm creating this with two different colors. Okay, let's go and create a load balancer. That is our motive here, right? So let's go to the load balancer page. I'm not going to create a classic load balancer. I'm only going to create an application load balancer. When you click on create load balancer, as I told you, there are 4 types of load balancer. Application load balancer that works on the HTTP, HTTPS layer. Network load balancer, which works on the TCP, UDP and TLS layers. And we have a gateway load balancer, which I told you, which works on the third-party appliances for your virtual, any of your virtual software appliances you have. you can use that. So you can just go through this. Your client makes a request to your application. The load balancer receives the request based on the route table within your VPC, and then the load balancer routes the request to the target group consisting of scalable fleet of applications like firewall, deep packet inspection system. You will have a lot of networking stuff. You can put it here. So if you're a network geek, then you can go and explore this, but we are not, this is out of the scope for us, at least for now. Okay. And as I told you, we have a classic load balancer, that's a previous generation. Click on this, and there are some. See here, August 15th, AWS will be retiring EC2 classic network on August 15th, 2022. We have another 15 more days if we need to create this classic load balancer. Right? I would recommend not to create this. Of course, you just need to know this if you get anything for your exam. See, this works in all the layers. There is no any customization that you can do. It's just a straightforward, right? So let's go and create an application load balancer. Again, application load balancer is under free tier. Network load balancer is not free, and you will get a static IP in network load balancer, but not in the application load balancer. Okay. So earlier days, there were a lot of network engineers who can do this. A normal person cannot do this, but we in the cloud, after all this are like matured now, we are just clicking a button and creating our load balancer. Okay. So it's just very easy to create. Just follow me through, and if you have any questions, please stop me. Okay, let's give a load balancer name. It can be any name you want, right? So people normally give their application and some other names, right? So let us put my ALB. My ALB name, right? Okay. Now scheme. I told you, right? We have two types of load balancer. One is internal facing and one is external facing. External facing will be internet facing. Internal facing is within your private thing. You can use it for your database and stuff. So this is internet facing because I need to access my load balancer and do these two applications. Now, IP address type. There are two types of address, two types of IP addresses. One is IPv4, which is a 32-bit IP address, and that IP address is our normal IP address like 1.2.3.4. This is an IPv4. We will talk about IPs and IP, all these types when we are studying about VPC networking, right? So IPv4, this is nothing but 32-bit. So each bit is 8, so 8 into 4, 32. And we have something called IPv6. That is represented like this. That's called IPv6, and that is like kind of 56-bit, right? It is very huge. Okay, so right now let's focus on this IPv4. This is what we will be using currently, and we will, when we study about the networking, we will talk about this IPv6 and why we need the IPv6 and what is the advantage of this, right? We'll see that later. Don't get too much confused now. Okay, so IPv4, when you say dual stack, this particular load balancer can take traffic both from IPv6 and IPv4. Right now, only IPv4, we just have only IPv4. Leave all this networking default because you don't know, right? Unless we learn this networking, you will not know. Leave this default and only make sure you select all the availability zones that are there under that region. So that means it will include all the, you will have the capability to add all the machines that are created under these availability zones. If you specifically select only US 1A, it will only attach the machines that are running in US 1A. We don't know, right? Tomorrow, if I create two more, it can go into 1A, it can go into 1F, we don't know. So for that, we will go and select everything. Of course, only US East 1 will have 6, everything will have max 3 only. Okay, so don't worry. Security group, right? Here is wherever this one is. Now, if you go back to this one that I showed you, yeah, this one I showed you, we need a security group. We will create one security group. This security group should only listen on 80 or 443. Right now, we don't have any certificate, so I'm not going for 443. So we have to create one particular separate security group to attach to this load balancer. Okay, so let's go and create that security group. Just say create a security group. It will open in a new window. So let's call this as my LBSG, my load balancer security group. I don't know if it is already there, but still Let's try to create it, right? My LBSG SG and leave this VPC. For now, we are using the default one. Once we learn about VPC, then we can go play around with our own VPC. Now, as I told you, all custom security groups by default, the inbound rule is denied. Okay, only outbound rules are enabled. It's allowed because they are stateful. You should rewind back to the last class. We would have seen that. Okay, so let's go and put an inbound rule saying, okay, the traffic type is HTTP. Okay, HTTP, it's by default HTTP is 80. Suppose if your application is running some other port, you have to choose custom TCP, and then you have option to go and change this number, whatever you want. Okay, so for now, let's put default 80. From where? From anywhere, because it should be internet, right? Anybody, you can access, I can access, so everybody can access. So that is this one. You can put a description, just say my LBSG. Okay, and go down and say create security group. After you create this security group, come down here. Sorry, refresh here and go and see. You will see my LBSG. Click on this one and delete the default one. Okay, now what will happen? We have this particular this one. So it will, we have created a separate load balancer for, separate security group for this are attached, and we have a separate security group that is attached to this EC2 machines, right? So we have web access attached to machine and my LBSG attached to this load balancer. Now this is where our listeners are, right? So it will listen what it needs to listen. It has to listen on the protocol 80. Okay, and then after you do this, we have to create a target group to attach this machine somewhere, right? So let's go and create a target group and then attach to this target group. Just remember this picture. Remember this picture. Now we are creating this one, and we need something to forward this to, and we are creating a target group with these two machines, right? So what are these target types? The target types, as we saw there, it can be either instances, it can be IP address, it can be a Lambda serverless function, or it can be another load balancer also, right? So right now we have only instances, so we are going with instances. What is the protocol? The traffic comes in 80, that is fine. What is the protocol version? It supports both HTTP 1, 2 and WebSocket. We are just going with only this one, HTTP 1. Okay, so it supports both HTTP/HTTP 2. When you say specifically HTTP 2, it supports only version 2. Very important here, right? Now we need to do the health check and say that machine is up and running. For this, what we will do, we will use the path where it has to do the health check. So where it will do the health checks, it will do here /index.html, right? This is the page actually this is our application index page, right? You can give index.html, or even if you give without that, just say /, it will point to that. So that is what we are going to do here. So do the health check on this application itself to make sure in this path, but you can also have a separate path for health check. For that, what you need to do, you need to get into your application, have a folder called health checks or HC, and inside that you have a.html, and will keep on clicking on that one to see if it's getting a response back or not, right? So if you are in a production support team, by chance, or if you have heard of this name, they will have something called keepalive.html. You guys would have heard this name, keep alive, right? Keepalive.html. So all the applications, right, that we are running in production will have a keepalive.html page, and all the health checks will be monitoring this keepalive.html, not our direct application. Okay, so you can write this and do that also. It's up to you. Okay, so right now I'm just doing it on my index itself. Okay, now there are some health check settings we can set. So what is the health check that we need to do? Even though my request comes on 80, but still I can overwrite the port. I told you, right? For a dynamic port, when the port comes 80, go and change it to 80.99, right? You can go and overwrite the port, dynamic port. But here we are not overriding. Let it be on the health check can be on 80 itself. Sometimes what happens, the keep alive will be running on separate port, say 9662, for example, right? That's up to you. In that case, you need to override the port because the traffic is coming in 80, but it has to do the health check on 9662. But right now, In our case, we are doing both on the same port, so we are not overriding, we are only just doing a traffic port. So whatever port the traffic comes, do the health check on the same port.
So Chandra, one thing, like here in health check, we are giving only one index one. So we have to give two, like both the machines IP here only, or we
No, no,
have
no,
to
no.
create separately?
No. We will not specify the IP anywhere. Okay.
Okay.
So after we attach these machines to the load balancer, the load balancer knows and goes to all the machines which are attached behind to search for that slash index.html, and
Okay.
it will report healthy or unhealthy.
Okay. Got it. Yeah, thanks.
So healthy threshold means the number of consecutive health checks successes that it needs before it's deemed as healthy, right? So let's make it between 2 and 10. Let's make it 2 because 5 means it will take some time to report it healthy. So we will make it 2. Minimum is 2. Unhealthy threshold, similarly, suppose number of consecutive times, how many number of consecutive times that you have to fail. If it fails, then you need to say it is unhealthy 2 times. If it is unsuccessful 2 times consecutively, then make it as unhealthy. Timeout, the amount of time in seconds during which no response is failed, means a failed health check. It's not getting any response from the machine. How much time it has to wait? Maybe 2 seconds, right? Of course, we know everything is running, but in real world, you can set it based upon your requirement. Interval, approximate amount of time in between the health checks. So first health check it has done. Second, we are saying 2 consecutive, right? So the time interval between one health check and another health check, keep it as default is 30 seconds. Let's keep it as like 10 seconds or 5 seconds, right? Try to keep this minimum when we are learning, but the actual you need to set up this as per your requirement and application, right? Success codes. You can have success codes from 200, anywhere between 200 to 299, right? By default, all HTTP 200 is by default success and response is okay, right? So let's keep this 200, but still you can give multiple values like 200, 201 like this, or you can give a range. You can also give a range of this one like 200 until anything that comes between 200 to 210 is deemed as success. So that way you can go till 299 because the error codes or the success codes, right? You have different error codes and success codes. It never starts with 1, it starts with 2, just like this: 2xx, 3xx, 4xx, and 5xx, right? So these are all some of the errors that you will commonly see, right? 200 errors are always success, always okay, the response is fine for that, right? So 404, it says not okay or page not found, right? Like this, you have this kind of errors. You can go to Google and check for your all HTTP error codes. It will give you all different types of codes with the explanation, right? You can go there and check that as well. Just give me 1 minute. Just give me 1 minute. Okay, so these are all some codes. You can go and check your internet. A lot of things are there. So when you do like this, right, you need to ask yourself some questions. Go and search. You will learn something new, right? So that's how like we learn new things, right? So let's keep this as 200 for now. There are some tags, as I told you, tags are optional for if you want to tag your this particular resource, the ALB. You can go and tag this so that when your finance team is getting the bill, they know that it is created by your team for you. Then do a next. Okay, we have to do it. Sorry, target group name. Let's put it as TG1. You can go and give whatever name that you want. Probably mostly they will be giving their application name because everybody will be using the same AWS account. So when they log in, they can go and search the target group or the application load balancer using resources using their application name. Application names are unique, right? No two applications are same at least the names are not same. Maybe the functionality might be the same in a bigger company. Okay, so a guy in the first floor will be doing the same functionality with their application. The guy in the 7th floor will be actually running the same functionality in a different application name. That's all. And it will take 5 years for them to find out and then consolidate. Okay, so don't worry, we always have work. Okay, so do a next. That's what you, that used to happen, right? Now these are all the instances that we have currently in this machine. Now what are the machines that you want to register the target? These are the available instances. It is up to you to go and select the registered target. You only know what is running in A, what is running in B, whether this needs to go behind the load balancer or not, that you need to decide, right? So all the instances will be here. So let us select both the machines, and you need to say include as pending below, right? Click on this one. So these are all the targets you need to review. These are all running. Okay, fine. EC2A, EC2B, and this will always be first state will be pending. Okay, then now you create a target group. Okay, after you create a target group, come back here, refresh this, and see, you will see your target group here. Select the target group, right? And you can add additional listener. So this is for HTTP. If you are doing HTTP, the other one should be the other port. It cannot be the same port. You cannot again do 80. Okay, just keep that in mind. You cannot again do 80. Okay, it will throw error. So please make sure only one port it can listen at any point of time. So you cannot listen 80 on two different listeners. Then any add-on services you want, you can add. Just leave this all default. This is a summary. Again, you have tags for your particular this resource. You can go and add it. It's non-mandatory as per AWS, but your company will be enforcing this. Create a load balancer. This is the load balancer. See, this is the A record, the DNS name that got created. This is the name that we need to give it to our customer or map our domain name to this particular DNS name. We never have any IPs here. Okay. Now go back to this target group and click on targets and see it says unhealthy is 0 because you remember we set up this target health. So now it is checking. If it is consecutively 2 times healthy only, it will say it is healthy. So now it is actually registration is in progress because just now we attached the target group to the load balancer. Now load balancer is making sure it's going and hitting and making sure the system is healthy. It is still not healthy because it has to meet all those health check criteria, right? Once it is go to health checks, and here is where we have.
So Chandra, how to make it unhealthy? Suppose, is it possible to do it manually also, or maybe some?
Yeah, you can. Now we are going to mimic that, right? After we see it's getting diverted correctly. Now we need to prove
Okay.
that if it is unhealthy, it should not send the traffic. That's what I told you, right? In
Yeah,
the theory. So we need to prove that, right? Let's go and see how to do that. There are multiple
yeah.
ways to do that. Let's see. We'll try to mimic a failure scenario also for you. So you just need to hold on for some time until this guy actually gets healthy. Okay. So now we just gave only 2 seconds, 5 seconds, and those things also we just need to wait. But assume that you are given 30 seconds, 1 minute and all, you will really need to be patient. Okay. Okay. This will take some time. Once that is healthy, then this provisioning state will become active. Only when that is healthy, it will become, this state will change from provisioning to active. And by the time you can go and copy this and see if your load balancer is working, right? If your load balancer is working, then let's see if the traffic is diverted to blue and red. Still not, so we'll have to wait for these guys to become healthy. See, they both are healthy now. Okay, now when you go back and refresh here, see it is active now. Now you go see here, already the traffic has been gone to blue now, right? I told you round robin, so it will go and choose the machine. So we have a, now just remember this one, right? Now we are here, we are on the load balancer. Now we have now directed to some blue color here. Now if I go and refresh, we have to see whether the traffic is moving to the other machine also, right? So let's go and try to refresh and see if our load balancing works. See here, you saw now. Can you see the difference now? Our load balancer is trying to route the traffic to both to all the healthy machines that are there running the same application. Of course, for us to make sure it is going, I've just changed the color, but ideally in the real world scenario, you will have the same application running everywhere. Okay, any questions here, guys? Okay, now I can access here also, right? See, I have given full access here, so I'm able to access this. Even if you go to this 44.2.2 22.3, you'll be able to access. Now we need to restrict this. How do we restrict this? As I told you, you remember when we talked about security group, I told you a security group's destination source can be itself. It can be another security group. So let's go and try to change that security group, right? So now what will happen? My LBSG is all fine. So the traffic comes from the user, it comes to the ET, it forwards it. Now actually my machine is attached to this web access. This is where I have. Let's go and see what is there in that, right? In my inbound rules, if I go and see what I have done, I have basically allowed all traffic from everywhere. That is why I'm able to access this both, right, from this machine directly. Now let's go and change this and see what happens. Now I want to restrict this. So I just say delete and add a new rule saying HTTP when the traffic comes 80 from where? From another security group. Which security group? Only when the traffic comes from my load balancer security group, you please allow, right? You please allow, so the users cannot directly access these two machines. Let's go and prove that, right? Save this fellow first and go here and now go and refresh these guys both and see what happens, right? You see this still going on both, right? It's not coming. Let's see if it is not coming, right? It will search for some time and it will say it is not found or connection timed out, right? It will say something and it will come out. Let it come out. Then we will go and check in our LB whether we are able to access or not, right? See here, as I told you. And remember, when we talked about load balancer, I told you whenever you see this connection timed out, you have to immediately go and check your security group. It's a security group issue. Now we know that we have mimicked that and we are able to see both are gone now, right? Nobody can access this our public machine directly. Now go back to this one. So you are able to access. Why? Because whenever the traffic comes only through this security group, you have to allow. Now we have allowed the traffic and our load balancer is now working and all our users can access only our application through the load balancer. They cannot, even though they know this public IP, they cannot put this. Okay, this is how we did this one. Now if you go back to our notes, if you see, same thing we would have explained here, right? See here, this is for the load balancer, this is for my machine. The source can be another security group also. So we are saying only when the traffic comes from this security group you allow, and that's what we have done. Okay, any queries here, guys? Are guys clear? You're able to see now, right? Okay, how this load balancer works. Okay, now let's go back and make sure one of the guy is not healthy, right? We have to mimic that also, right? Let's make sure that one of the guy is not healthy. Let's say this blue color is not healthy. Go and select that guy. Let's go and connect to that and see what happens, right? Let's go to this one and stop this machine, right? Either you can go and stop the machine or you can go and stop the service. It's up to you. I'm going to stop this machine, even though it is still connected to our this one, right? Okay. Once it becomes stopped, let's go and see what happens. Assume that there is some problem with this machine or it got crashed or it got stopped or something, right? Something happened. Again, keep in mind, the traffic will be diverted to the machine only if the machine is deemed healthy. Okay. We need to prove that this machine is unhealthy and the traffic is not going to blue color. It's only always going to red color in our case. Okay, it is stopped now. Now go back to the target groups, okay, and do this one. See what's happening. The target is in the stopped state, so it is unused, and go top. See here, one is unused, only one is healthy. Now let's go back here. What will happen? It should never put our traffic to here. Blue color. It should be always only red color. How much ever you want go and click, it will be red color. So this means only if your targets are healthy, it will forward the traffic only to healthy instance. Now, if I do again go back and bring this again back, let's see. Now assume this. I see this IP address is now going to change, right? As we saw last time, when we stop and start, the IP address is going to change. You need not worry about that, because all that we are worried only is about the DNS name. The DNS name still remains the same. The DNS name still remains the same. Let's wait for this mission to come up, and let's go and check in our target group and see if it is healthy. And now your traffic should be diverted to both the machines. So this is how your load balancer works. Okay. Okay. See, it's already healthy now. Now let's go back. See, now the traffic is going to the previous machine, which was stopped and started also, even though we have a different IP address here. This IP address you see here, 52.201, actually it was 44.201. Okay, now you can see that, right? So only if it is healthy, it will route the traffic to. So this is your load balancer, application load balancer. If you are clear on this, you don't even have to go and read or do anything. This is a fact, that's all. And this is what will be asked in your interview or in your exam. Okay, so unless you actually do this, you will not remember, but these are all the points that you need to know. So coming back to network load balancer, it's going to be the same thing. There is no any issue. One more thing that you just need to know in the target group. See, let's go to the target group. I'll show you where to write those rules, right? Go back to load balancer. Select the load balancer and go to listeners. And this is where you can go and edit all your rules, right? What are the rules I have, right? This is a default rule. Oh, so these are the rules that I have. What is the condition? When the host header has something, forward to this one. When the path in your path something is there, go and do that, right? In your HTTP header, if something is there, forward to another target group. HTTP request method is get or post or delete, do something. Query string, when along with this, if I pass like this, right? For example, query string means if I say name equal to Chandra, right? So I can say if the query string name equal to Chandra, then go to different set of machines, right? That also you can do it here. And you can also say source IP. If my source IP, if I'm browsing from the IP 1.2.3.4, then go here, right? All those things that you can do. Okay. So these are all the things that you can put your rules here, and you can do this, right? And if you are doing,
yeah, and if suppose we want to think that another machine we want to connect with the same EC2, that one, so we can create the same instance again and we can connect using this letter also, so that 3 machines can be shown.
Yes,
with the same.
go ahead and, yeah, you can go ahead and create this machine and go to the target group and add the target, register the target. That's all.
That's all, no? So multiple machines.
Multiple you can just for example, we showed 2. You can have 220, yeah. Or today you create 2, tomorrow you create 2. You can go to add that 2. If you wanted to add that as part of the load balancer, you can go and add that.
Okay, yeah. Thanks.
But all that needs to be done through your target group. You can go and register new systems in your target group. So these are the ways that we can go ahead and do. Suppose if you say, if for example, if I say my path, right? Path what? If my path contains search, if my path contains /search, right? Then you forward it to add the action and say forward to redirect to return fixed response. So forward to, it will show you all the target groups that are there. Right now we have only one. You can create multiple target groups and select here. That's one thing. right? And then you have another thing to do. You can also add action and say redirect to something else, right? Redirect from this one to HTTPS and all those things that you can put this one here. And if something is coming, and you can always redirect to path. Okay, let's put this path. And you can also always send a fixed response back saying, hey, sorry, we have moved out, right? And you can put the message here. We have moved out, this is not available. Please contact your administrator, and all those things. You can put a fixed response error. So 503, whatever errors I told you, right? 245s, put something and you will get. So if they are getting 404 error, don't say page not found, say, hey, please contact the administrator and give the link to the administrator or whoever they need to contact, right? Give it here. So whenever you get that error, right? Say for example, I get my application is not available. I get a 404 error. I get a 404 error. Then you simply need to just say, please contact your administrator. So every time you get this 404, it will return a fixed response back to the user. So lot of things that you can do based on different use cases. Okay. So this is on your rules. That's what we talked about. Now let's quickly jump to the other stuff, right? We have spent a lot of time here. Okay, there is something called load balancer stickiness. So it is possible to implement stickiness so that the same client is always redirected to the same instance behind the load balancer. Suppose you have two machines running A and B, and you want all the client to be always going to A, then you can enable stickiness. This works for classic load balancer and application load balancer, but not for network load balancer, because network load balancer doesn't use cookies. Cookies are always used from browser. Okay, so that's why only layer 7 will work. There's a cookie. The cookie will be used for your stickiness. It will have an expiration date. Until that expiration is there, the cookie will be there, and you can make connection to the same machine. Okay. So just if you want to make sure the user doesn't lose his session and all those things, you can use this. But there is a catch to it, right? You have to make sure you are having the expiry date not too long, right? If you have that, what will happen? There will be a load on that particular server, and the other machines will still have open. It will be open for traffic, but you will not send any traffic there. So that means one particular machine will be bombarded with the request. So you need to be careful on that. So this is how you do, right? We have client A, client B, client C coming to our load balancer. These are two machines. When you enable the stickiness for client C, what will happen when this guy comes here and goes to this machine? A cookie will be returned to this machine, and until that cookie expires, it will always be directed only to this machine. When we might use this use case, right? Suppose if you are paying for a credit card, right? If you're paying in your credit card, you have come to this machine and payment is started processing in your bank. How our payments happen when we do online transaction? It's very simple. When you enter your credit card, your security, CVV number, and all the other details, and click submit, what will happen? When you click submit, that request, your credit card number along with the encryption and everything, will be gone to your gateway providers like Visa, MasterCard, all those people. It will go to the gateway. Your application cannot do anything. The request will go to the gateway. The gateway will talk to the bank to see, hey, this guy, whether he is attempting to pay 100 rupees, is the balance available, all those things, right? The bank will return only two values, yes, no, nothing else, right? It will only return yes, no, success, false. It will return back to the gateway. The gateway will send the same response back to your application. Your application has to process and find out from that XML. It will just say it as an XML. It will send back as an XML. It's all predefined XMLs. Okay, you cannot have your own XMLs. They are all predefined by the bank. So they search for that value, and based on that, it is a success or failure. They will display the message, hey, you are successfully paid and your delivery will happen and so and so date, right? This is what is exactly happening when we try to go and pay for something. We are thinking that our application is doing the payment. No, everything is happening in this way, but our application is just an end user, right? So it will just receive the response and throw it back to the user. If the credit card number is invalid, how do you know, right? You are not storing any of that then, right? So only the bank gateway will give you. Now in this scenario, when you are trying to pay your application, the client is coming here and paying. Assume that it has gone to the gateway, right? If you are not enabling cookies for that time, what will happen? This guy refreshes sometime, right? That's why in all the browsers, when you are paying, they give you two words there. Please do not refresh, don't hit back button, right? You remember? when you are paying. That is the reason. If you kind of go and try to refresh or go back, what will happen? This guy session will be gone, and next time again this session will not be there. So you have to log into the application again to do the payment. So in that case, if you enable that is where they would have enabled this stickiness for us, and we would be always sticking to this machine, because the traffic from this machine will go to the gateway. The gateway's response will come to this machine only, not to the load balancer. Okay, so that is why we have to enable the stickiness. All the process that we talked about the bank will take place in fraction of seconds. It's in milliseconds. So suppose, say that if your transaction is happening 5 milliseconds always, right? So what these guys will do, they will enable the cookie for 10 milliseconds. That means they are waiting for the response. If it is above 10 milliseconds, you will say, hey, it's timed out, can you please try again later, right? Something, they will throw you the message. This is where your load balancer stickiness comes in, and this stickiness expiration date is very, very important. You need to make sure that is the time is given correctly. If you make it 24 hours, what will happen? This guy will always be coming to here only, and he will be bombarding this one machine only, while this machine is still available, right? So this is what your load balancer stickiness. Any questions here, guys? For stickiness, why we have to enable this? Stickiness is not on the load balancer, it is enabled on this machine. That is why we have to wait until the response comes from the bank, and then you throw the response back saying, hey, you are successful, not successful, whatever it is, right? But if you enter a wrong credit card number, right? Wrong credit card number in the page that you are providing to your customer, what is happening means, they are not sending it to the bank to verify. Every time when you send to the gateway or to the bank, your application or your company needs to pay some money to the gateway. Okay, so to avoid that, what they will do, for they know what the Visa card will start, Visa card type numbers are, what are other cards, like say Mastro or MasterCards, right? They know all those numbers. So they will do a JavaScript validation, client side validation. If your number is not correct, they'll say invalid credit card number when you hit the submit. Only if it is valid, I mean, at least the pattern is valid, then they will send it back to the gateway. And if your card is actually, if it's a MasterCard, that is fine, but that's not the correct number, that our I as an application will not know, but only my gateway will know. But I have to pay the gateway to do the check. Okay, they have to pay some fees for that. This is what is actually happening when you try to pay. So next time when you go to Amazon and buy something, this is the process you need to think about, what is happening in the background. Okay, any questions, guys? Anyone? Okay, we'll move on. So we have something called cross zone load balancing. So what is cross zone load balancing? I have 3 availability zone, AZ1, AZ2 and AZ3. Without enabling this cross zone load balancing, you have one load balancer here, one load balancer here, one load balancer here, and you have 2 machines, 2, 2 and 1 machine. So whenever traffic comes in AZ3, always if this will go to only 1 machine. When more traffic comes, the traffic needs to wait because we have 2 machines. When you enable cross zone load balancing, so when the traffic comes, if any of the machines are free here, it will divert the traffic to other availability zone. But please make sure all these 5 machines has the same application or the same functionality that you are trying to forward to. So with cross zone load balancing, each load balancer instance distributed evenly across all registered instances in all availability zone. That is why I told you to select all the availability zones. That's why I told you to select all the availability zone. Even though the machine that I created, 2 machines are in US East to 1C, I asked you to select all from 1A to 1F. Otherwise, each load balancer node distributes requests only within its node, within its availability zone. And if there are 3 or 4 requests coming here, this guy will suffer and we have to wait. But if you enable the cross zone load balancing, then this will go here. The disadvantage with there are some advantage and disadvantage. The disadvantage is like you need to make sure all these applications are same, and then when you pass the data from one availability zone to other availability zone over network, you may need to pay some charge. So you need to keep all that in mind. Okay, so if you are going to earn 100 rupees, there is no problem in spending 1 rupee, right? But if you are getting only 10 rupees, you cannot spend 2 rupees. So you need to make so many decisions on this, right? So classic load balancer, the cross zone load balancing is disabled by default. There is no charge for inter availability data if it is enabled. there is no charges. For application load balancer also, it is always on, you cannot disable it. By default is it enabled, and there is no charge for inter availability zone data transfer, right? But whereas network load balancer, they are disabled by default, and you pay the dollars for inter availability zone data if enabled. The reason is it flows through network layer, right? It flows through network layer. This is your cross zone load balancing. Any questions of load balancing before we start off on the auto scaling? Anyone? I think we have seen so much today.
I
And
think
we
we
have
are
seen,
good.
yeah. So if guys, please go through this video and try to work it on yourself and see and mimic and see if it is working, not working, all right, then you will get used to. Let's talk about auto scaling. So in real life, the load on your website and application can change, right? Say for example, you are having an e-commerce site and tomorrow is Sunday and you are planning for a sale, right? You have a 2 machine and your applications are all set up, everything is ready, and you know that you are expecting 100 people to 100 requests to come, and you are very sure that 2 machines are enough for me. What happens tomorrow? There is 1,000 people coming into your site, right? Your performance will go down or your application will crash, the site will go down, so many things can happen. And while your customers are coming in, you cannot go and create the machine and keep on adding it manually, right? That is where your auto scaling group will come in. When there is a spike, sudden spike, or the more demand, then you can bring up mission automatically by writing few configurations ahead, right? You have write your all your configurations ahead and configure them and keep it ready whenever that condition meets. When I say my connection is more than 80, right? Bring up another 2 machine, and automatically we can add those 2 machines into our load balancer, which is already available. So what will happen? You create a machine here, it will automatically create a machine, it will bring up my application, and it will add it to the load balancer. So your users load will be spread across now 4 machines. Okay. Now there are 10,000 users coming in. Bring up another 2 machine. Bring up another 2 machine. Okay. At the peak of your sale day, that is, say for example 2 p.m., 1 p.m., 2 p.m., you may have 10 systems there, and it's all behaving in the same way. Your users are happy. You get more business. Everything is done. What will happen at 5 o'clock, right? The traffic gets reduced, right? So it becomes from 1,000 to 800 to 600 to 400 to 300. By 5 o'clock, your actually sale is over. So by 5 o'clock, all your sale is over, everything is gone. What will happen to those systems? You can write it in such a way, it will delete all that system and remove from the load balancer and keep only the 2 that you had initially. So now what will happen? You are creating 10 machines on demand, and then you are paying for that 8 hours. And after that 8 hours is over, you will continue to pay only for the 2 machines that you already had. So this is called auto scaling. That's called scale out and scale in. When you say scale out, means increase the number of systems. When you say scale in, you reduce the number of systems. There are 2 types of scaling. One is called vertical scaling. One is called horizontal scaling. Okay, you need to understand this. Okay, one is called vertical scaling. Vertical scaling. Okay, when they talk about vertical scaling, they will use the term scale up and scale down. Okay, and when they talk about horizontal scaling, we will always say scale in, scale out and scale in. Okay, please keep in mind, if somebody is asking you to scale up, it is a vertical. Scale down, it is a vertical. Okay, when they say scale out or scale in, then it is horizontal. Please remember these terms for your exam or for your interview. So let's see what is vertical scaling and what is horizontal scaling. Vertical scaling is like, that's a one guy, that's a one machine, okay, who is eating and putting a lot of weight, right? So today he's 10 kg, tomorrow he's 20 kg, he's 40 kg, 60 kg, same guy, but he's becoming fatter, fat, right? That is called vertical. So you have one machine with T2 micro today, you are adding another T2 small, you are changing the instance set, you're adding another RAM, you're adding another so much storage RAM, you keep on increasing, that is getting blown up just like a balloon, right? So that is vertical scaling. It's a single machine, but you keep on increasing the resources. It's a single guy who is eating more, and is now becoming 100 kg. That's a single guy, right? But downfall to that is vertical scaling is, it's a single machine, single point of failure. the machine can go wrong, everything will go wrong. That is your vertical scaling. Horizontal scaling is, you know what? Okay, I have a machine with 1 GB. I want to add another GB. I don't add a GB. Instead, I add a machine with 1 GB, the same configuration. Another machine with 1 GB. Another machine with 1 GB. So I have the same configuration, multiple machines. Now, in this case, what will happen? If one machine goes down, I have another 4. If another one goes down, I have another 3. Right? So that is the advantage of doing the horizontal scaling. Horizontal scaling is recommended by AWS, but vertical scaling also people do when they use the database, but that is not recommended, right? At any point of time, that can blow up, right? That can blow up. So this is the difference between vertical scaling. Think of a guy whom you met in your school days, was very thin and now he's very fat. That is a vertical scaling, right? So vertically you scale. We always say, right? Oh, you're not good. You're not growing sideways. You're growing like vertical, right? That's what we used to say people, right? That if they are very fat, we used to say them. So that's a vertical scaling, and the horizontal scaling is like multiple things, right? So when we talk about auto scaling, we are invariably meaning that is an horizontal scaling. We always talk about the term scale out and scaling. Any questions here, guys? Any? So just understand this difference between vertical, horizontal. Either think of you or your friend. If you have become very fat, think that you are a vertical scaled guy, and if you are not, then you have kind of I cannot say you're horizontally scaled because we don't clone ourselves, but that is how that it actually happens. Okay, that's fine, good. So now with this background, if you go and take a look at this, you'll be able to understand. So in the cloud, you can create and get rid of servers very quickly. The goal of auto scaling group is to scale out, add more instances to match the increased load, scale in to remove the instances to match the decreased load. At 5 o'clock, scaling. At 9 o'clock, scale out. Peak hours, keep scaling. But how much do we scale, right? That also you can say at the maximum, it can only scale up to 100 machines, 10 machines, right? So ensure we have a minimum and maximum number of machines running, right? And then you can automatically register new instance to a load balancer. You don't have to create a load balancer manually and keep adding the machine. Automatically it will register. We are going to see all these things, okay, quickly. Okay, here is where we have. So these are all the original size. You have to, these are the 3 parameters you need to specify: minimum size, desired capacity, and maximum size. Minimum size is 1, for example. Desired capacity can be 2 and maximum can be 4. The desired should be between minimum and maximum, whereas minimum and desired can be the same number also, okay, but it should not be less than the minimum. Suppose you say minimum 3 and desired is 2, that will not work, right? So it will always, your cloud will make sure you get the desired number of machines, okay? And this is how it happens, right? Already I have a 2 machine, we have a 2 machine that's running, okay? Now I create an auto scaling group and add this guys and then bring it to the load balancer. So once I finish my job, automatically this will get deleted and I will still be left with the one that I have already had the machine, and I pay for the extra machines that I used for 8 hours, and then from the next day I keep paying the regular bills, right? That's how this happens. Assume that all this you are trying to do manually using setting up machines. You don't know the pattern, right? You don't know tomorrow 10,000 people will come or 1 lakh people will come. So how you will go and buy the hardware, right? So this is where your auto scaling and your cloud comes very, very handy. So auto scaling, there are some attributes. So we have to create some launch templates or launch configuration. So when we talked about EC2, I told you when we talk about templates, we will see when we talk about auto scaling, right? So you have a launch configuration, you have to define a configuration predefined, right? So launch configuration, nothing but what to create, right? What to create. I want an AMI with this instance type. I want this application to be loaded. I want this many volumes. I want this security group, this key pair. All these things you define in the launch configuration. That is called what you need. How you need is nothing but your auto scaling group. Auto scaling group will say, okay, how much system you need, what is the maximum, what is the minimum, everything that is for the auto scaling group. So you have a launch configuration and a launch template, and you need to create that launch template, and from there you need to create a auto scaling group, and automatically your machine will create based on the different conditions that you see, okay? And you give your network load balancer all the scaling policies, and based on that it will scale and scale in, scale out, okay? Let's go now and do this. Okay, let's keep this this guy as it is, because we will need the machines to be added to our LB. So let's go and see. Go to the launch configuration. You have auto scaling. Under auto scaling, you have launch configuration, is where you say what you need, what type of machine you need, right? Because it's a template, right, kind of thing, right? So you go and get that. So before we do that, go and select one of the machine and select your AMI ID that is already there, because you cannot remember the ID. Just scroll down here, you will see this AMI ID. Just copy this. So when we create a launch configuration, we can create with the same this one. Let's go and create a launch configuration. And let me say this is a test LC, test launch configuration. What is the Amazon machine image that you need? We don't know the ID. So just go and paste this ID, and this is the Amazon machine image that is actually running already our application somewhere. Now instance type, what instance type you need? Okay, what is the type of instance you need? By default, of course, we will always go with T2 micro, because that is our free tier eligible. Okay, so please make sure that you are using T2 micro. Whether you want a spot instance or not, whether you want to attach any roles to that, all those additional configurations are here. Okay, you want to add additional volumes to that machine, you can go and add it here. Now this is a security group we need to select. So when this machine comes up, right, when this machine comes up, I want to add web access security group. So this web access security groups allows only traffic coming from your load balancer as of now. Okay, so I cannot access this machine directly. Keep that in mind. I cannot access this machine directly. I can only access this machine through load balancer. Now what is the key pair you wanted this machine to have? Please choose an existing key pair. So if you have some issue, right, you will be able to troubleshoot. So you say, yes, I acknowledge I have access to this key. And go on the top, go to the advanced details. Okay, scroll down. And here is your user data. Please add your script here, so your applications will come up whenever you do this, right? So let's go and copy this. Now what we need to do, we need to make sure this is coming from auto scaling. We need to show that, right? Let's put green. You can play around, right? You can play around from ASC. Okay, now this is the template that we have created. So when we create auto scaling, it will use this particular template to bring up this type of machine with this details, whatever that we have given here. Go and create a launch configuration. Okay, you have created a launch configuration. Once the launch configuration is created, next we have to create an auto scaling group. Again, please be very careful. Whenever you create an auto scaling group, the desired state, desired number, whatever you give, it will start creating that machine immediately. Okay, it will think that desired is 0 and try to bring it to the desired number. So let's go and create an auto scaling group. A lot of configuration here, please pay some attention. Okay, and let's put some name, my auto scaling group. Okay, now here you have launch template and launch configuration. We have created only launch configuration. Again, I will say you the difference. What is the difference between launch template and launch configuration? Right now we will select this, and then we will come back later on this. Go refresh here and select the launch configuration if you have created already, right? You can go and review here whatever that you have given and do a next. Okay, now you can select the availability zones where your machines want. You remember in the load balancer we selected all the availability zones. So I don't know, the machine might be created in 1A, 1B, 1C, I don't know, right? So go and create or select all the availability zones here, so the machine can be created in any of the availability zones, and those all the availability zones machines created will be added as the target if needed, right? Now click on next. I already have a load balancer attached to an existing load balancer. Yes, I have a load balancer. Whether you want to choose from the classic load balancer or your load balancer target group, I have a load balancer target group. Please add these machines into my TG1. Sorry about that. Yeah, TG1. health checks. Apart from EC2 health checks, you also have an option to do a ELB health check. So you can do a ELB health check, which will check health of your load balancer as well, along with the EC2. Now, health check grace period, the amount of time until EC2 auto scaling performs the first health check. So one machine it will bring, it has to warm up and then come, right? So let's make this as 120. 200 is by 300 is by default 5 minutes. Let's make it 2 minutes. Then additional setting, you want to add additional monitoring, you can go and add here, and you can also enable default instance warm up time. How much time, right? Default instance means it will show you how much minutes you want it to warm it up and bring the application, your system up, right? When you're having a bigger application and you are doing a bootstrapping, then make sure you have an appropriate number here. Do next, see here, this is where very important, you need to specify the size of auto scaling group. Say I say minimum is 1, maximum is design is 2, and maximum is always 3. Okay, 1, 2, and 3. So what will happen as soon as I create this and we are done, it will start going and checking in your EC2 whether it has any design system from this auto scaling group. No, so it will try to bring 2 machines first, and it will come to the desired state always. Okay, always it will try to match this desired state. Okay, scaling policy, there are so much scaling policy. Now on what basis you need to bring more machines, right? That also you can say. Okay, these are also some of the metrics you can say. Average CPU utilization, average. If you're having 10 machines, it's an average of those 10 machines. You can say average CPU utilization is 2%, bring up the new machine, right? We will do this later because first I need to show you the default one, then we will add this policy and see how it adds another 2 or 4, right? Whatever it is. If you check this box, enable instant scale in protection, it will not reduce. The machine will not reduce when the load reduces. In some cases, they will enable this. It's an optional for you. Next step is to see whether you want to add any notification whenever auto scaling happens. We will learn about SNS, the simple notification service. We are not going to enable it now. When we learn about this, then you can come back if you want, you can enable. Okay, that's nothing, just send you an email. These are the tags, right? These tags will be applied to all the machines there. So what is the name of the machine I need? So to differentiate from this one, I can say EC2 from ASG, right? So this is created from ASG. Okay, go review all the details here. Okay, before I do that, let me go to this instances and I'll VC instance state equals only the running ones we will see here. So only we have 2, right? Okay, now go back here and everything is fine. Go and see create auto scaling group. Once you have this group, see here, it is updating the capacity. You told design to be 2, but as it's found 0, go inside this auto scaling group, go to the activities, and you can see already 2 machines has started pre in service, right? See here, it has already started 2 machines because you told design to be 2. Okay, just hold on. Once it is pre in service, then once it is in service, it will start bringing it. Now, how all this happens, right? How does this machine know, right? I told you there is a CloudWatch service, so it will put an entry in the CloudWatch saying, hey, whenever something happens, you bring these 2 machines. So it's all event driven. It's all event driven by automatically. Okay, just hold on. See here, you see there are already 2 machines that has started initializing. Okay, now I go back to my target group and check my target group, what has happened to my target group. This is my target group. Go to my targets, and if you scroll down, see the 2 machines has already added and our health check is happening. It is unhealthy first. Okay, because what happens is after it has created the machine and installed our services, then only the health check will happen, but this will get added immediately and the health check will start. Okay, see here now, one has created a 1F, one in 1D. Since we have used all the availability zones, it has already added all the machines, right? So this is how it will work. Okay, just hold on for some time. and we will be able to, just to make sure that this particular the application is running, you want to check. You cannot check through browser. The reason for that is we told only if the traffic comes from the security group only it will allow, right? But you can go inside the machine and just do a local host, curl on local host, and see if you are able to catch hold of the application. So if it is all healthy, see here, we are already, our ASG is healthy and your traffic is being flown to ASG. See here, mission A, mission 2, which is already we had. See here, it's all healthy now. Go back to the target groups and go and refresh. See here, all the 4 are healthy now, right? So this is how your auto scaling works. Now we did not actually scale. It's an initial one. It's a initial one. So go back to auto scaling group and go and refresh this activity. See here what happens. It has already launched these 2 machines and everything is in desired. So what it has done this, right? Go and read this, right? At this time, a user created an auto scaling group, changing the desired capacity from 0 to 2, because we told desired to be 2, it found 0, so it's trying to change from 0 to 2, and it has created 2 machines. So this is where your auto scaling group will work, right? This is how it works. Now let's go back to the auto scaling. Now this is fine. This is the first time we have created. Now how do I increase to that 4 machines, right? Maximum. For that, let's go and edit this. Sorry. Let's go and select this and go to automatic scaling here, and you can add a predictive scaling policy or a dynamic scaling policy. Create a dynamic scaling policy. What will happen? Policy type is, you have 3 types of policy: target tracking policy, step scaling, and simple scaling. When you select step scaling, okay, it will use the CloudWatch alarm. Based on the alarm, it will trigger and take action and add 1 or 2 or 3 units, right? It can do that. Step scaling. Simple scaling is just, it will go and add number of units. That's it. Based on this one, and it will wait for another so and so seconds, right? Whatever that you specify here for the next mission to come up. Let's go and do a real time this one, right? So target tracking. Inside target tracking, you have all these things: average CPU utilization, network in, network out, and application load balancer request count. If there are more than 80 users, you bring up the mission. Of course, we cannot mimic that. So what we are going to mimic? We are going to mimic an average CPU utilization. When the average CPU of those 2 missions becomes 2, I'm just making it 2 because it is an average. If I put 50 or 60, we are never going to see that today. Okay. Let's go create this. Now this auto scaling has already, policy has been enabled, dynamic policy has been created. So that means when my CPU utilization of those 2 machines reaches 2%, please go ahead and raise another one, right? Create another machine. So let's go to activity. This is the place where you need to see all your stuff that is happening, right? Let's go here. Okay. So how and when this will start? As I told you, it will put one entry into the CloudWatch service. Let's go to the CloudWatch service and see what happens. We will talk about this service in detail, don't worry. But for now, just know that how the alarm is getting triggered, right? So when we created there, right? When we created there, see here, it automatically created target tracking my ASG, low alarm and high alarm. So when the CPU utilization is greater than 3 for 3 data points within 3 minutes, then this will become so first, whenever you create an alert, it will be in insufficient data because it needs data. It is waiting for the data to come. Once the data is there, there are 2 stages it will go. Either it will be okay or in alarm. Okay means it's all normal state. If it is in alarm, it will trigger something. Let's go and see what it will trigger, right? When it becomes greater than 2, what it is trying to do, let's click on that. So this is what we gave, right? When the CPU utilization is 2%, then what it is going to do, we can go down and see what it is going to do, right? Okay, when it is 2, the action would be to actually call the auto scaling group. See, it will call the auto scaling group and this will trigger. So they are all event based trigger or event driven architectures, right? So something happens, you do. That is why it is automatic. That is why it is automatic. See, already we are in one alarm. So if you go back to your machine, where is that? You go here, see here, your alarm has been triggered. So once that guy has triggered, sorry, I have to put this. Once guys have triggered, see here, is already started creating another machine because my average CPU went from C2 to 3. Quickly, you need to jump and go and see, right? A little bit difficult, but still you can do. Okay, see here, the third mission is already in. We had only 2. Now I have third mission. I just go back to my, where is that? Go to my target group and go and refresh here. I'll have my third machine. Target registration is in progress. It just created. So it will be unhealthy because it has to create the application. Just hold on for a minute. Everything will have the same this one. So we cannot find out whether from this one or that one. For that, what we should have done, we should have dynamically added the host names, right? Then we will see the difference, right? But of course, in real time, everything will be the same application only. Okay. So this is where your this will become healthy, and we will know that this guy is sending the traffic to all the 3 machines there. Right now, if I go back to one of these machines, everything is coming. Okay, initializing. Go to this machine, for example, take the IP. If your security group is allowing, then it should allow. But what we told, we will allow traffic only when it comes from the load balancer. That is why you will not be able to access your this one directly. See, everything is healthy now. So we are still seeing that all the traffic is getting diverted to all 3 machines. But of course, this 3 machine has the same content like this, like in green color. So that is why we are not able to kind of differentiate that is going to different machine. Whereas this one we have made it manual, so we are able to see in different colors. So this is your auto scaling. Okay. Now the traffic is more and your CPU utilization went up, and your this one has already created machine now. Right? So this is how it's trying to bring this. Any doubt here, guys? So I think whatever we talked about is where that we are seeing that in action. So that it has triggered and it has actually horizontally scaled out one machine extra, right? One machine extra. If you go back to this particular diagram that we were talking about, see here, we had 2 and already we had 2, the desired 2, and it has brought the third one up now, right? How do we bring it down, right? How do we bring it down? Correct? Okay. How do we bring it down? See, we have 3 instances, 3 desired capacity. Max is 3, so it has reached the 3. After the 3, it will not go because the max was 3 only, right? So 1, 2, and 3 we made it. Okay, now go inside this guy and go to automatic scaling. Okay, and go and select this guy and go and say disable this. Okay, now it is disabled. Dynamic scaling policy is disabled. So once this is disabled, go back to the activity. Now let's see what happens. Now again, this will not happen immediately because this CloudWatch needs to trigger saying, hey, I'm seeing something that's disabled so completely. So please bring it down. See, our CPU utilization initially went above that one, and that is where we are. 2.66 something is there. Now go to in alarm or go to all alarms. Now everything is okay. So now it is less than 2. So we got our systems back. Now we need to see if we are trying to, if it is trying to delete one of the machine. After some time, it will go and delete that. Okay, so go watch on your activity. You should be able to kind of find out that. Again, whenever something is getting deleted here, it will not get deleted immediately because we have already attached this machine to our load balancer. Assume that somebody is doing a credit card transaction there, right? Assume that somebody is doing a credit card transaction there right now, and we have reduced the machine. What will happen? That guy will not be completing his transaction. So what we will do, there is something called ELB connection draining. It's a 300 seconds connection draining will happen. So that means we will give 300 seconds for the user to before we throw out the user, and then we will bring down the machine from the ELB. That is called connection draining. So whenever we delete some machine, always connection draining will happen. Only then it will bring up your this one. So that's it. So that's how we will bring this down. Okay, and we can go delete this also, not an issue. Disable it and delete it. Here, this one is gone. Now go back and start refreshing your this one. Wait for some time because again, everything will depend upon the CloudWatch alarm that is getting triggered, right? See, both the triggers are gone. Go to the auto scaling group, wait for some time, and you will see something called connection, ELB connection draining. So it will start to drain your. So how this will find out? This knows that the desired to be true, but it has 3 machines, so it will bring down 1 machine. And how? What is the logic to bring down the machine? There is some logic to bring down the machine. It will not bring all the machines down. It will bring the machine which is older. That means if it is created at say 1 AM, 2 AM, 3 AM, we created one machine, it will try to bring up the machine that was created 1 AM, not the one latest created, right? So that's some logic. It will make sure it uses that logic to bring down your machines. Okay, keep refreshing for some time, then you will make sure that this will be desired will change. So this is how your auto scaling can happen. Okay, once you have done with auto scaling, you can go and delete this auto scaling group, then it will delete all these machines by default that you have created through auto scaling. Now I told you we will talk about launch configuration we saw here. So what is the disadvantage of launch configuration is you cannot edit this. You can only delete this or copy to something, but you cannot delete. Sorry, you cannot modify this. Suppose if a manager is saying to convert from T2 micro to T2 small, you cannot do that. So you need to recreate this. For that only we have something called launch templates. Launch templates. Okay, I told you we will see this launch template. Launch template is similar to launch configuration. You give all the details there. Nothing is different. Only thing that is the different in launch template is you can edit a launch template to a newer version. You can create a version out of the existing launch template and modify whatever you want to modify. So that is where we use this launch template. How these launch templates can be created? There are multiple ways to create launch template. One is you go to the running instance. Okay, you have some running instance. Select this running instance and go to actions and go to images and templates, and you can create a launch template out of this running instance. So you will get the same exact replica of this, whatever you have. Or you can go and create a new launch template also. It's up to you. You can create a new launch template and you can go and create your configuration just like your this one. I want you guys to try with this one also. Try and let me know if you are seeing any issue. Right now, go back to this auto scaling. You can see here. What is the target group? It will try to bring down one machine and the entire scaling will go off. Now, once you are done with this, okay, very important. Once you are done with this, 2 things you need to do. You need to delete your auto scaling group without fail. Okay, if you have your auto scaling group, always, even if you have their auto scaling group and try to go and delete this instance here, right? Where is that? So what I'm doing, I'm not deleting my auto scaling group, but I'm going and deleting a machine from this auto scaling group. Let's see what happens. See here, I'm actually trying to delete one machine here. I'm shutting it down. Okay. I'm shutting it down. Just go to the activity and see what happens. Okay, I'm shutting one of the machine down. This will take some time for all this to catch up. I've terminated this machine. Let me also go and terminate another machine that we created from auto scaling. So right now I have only one machine that came from auto scaling. Okay. We are done, guys. Just give me 5 minutes. We are done. See here, it's already launching a new because a new instance was launched in response to unhealthy instance needing to be replaced. Already I deleted a machine, but we told we need 2 machines, always should be there. But right now we have only one. So what it has done, it has already started bringing up another machine. So this is what it will happen if you don't delete your auto scaling group, but keep deleting the machines from auto scaling group. It keeps on creating the machine and you get charged. So once you are done with all the exercises, then I would recommend you to go and delete your auto scaling group. So all the machines that are created as part of that group will be deleted. Okay, see here, the second machine is just created now. See, initializing. So it will always make sure that the desired is always met to do. Okay, so this is how it happens. So what we need to do, we need to basically delete our auto scaling group. Now see what happens when you delete your auto scaling group. You need to confirm that you want to delete this. Delete it. See, when you delete it will make everything 0. Okay, go back to auto scaling group, go back to the activity and go and refresh here. See what it is. I told you, right? Waiting for ELB connection draining. So it will wait for the connection to drain out from the ELB because you are inside the ELB. There may be some transactions going. It will wait for that time and then boot these guys outside if it doesn't meet within that time. So it has already started the connection draining. It's called connection draining. It will drain the connection and it will go and delete all your machines there, whatever we created as part of the right now. We have these 2 machines. See here, we have the 2 machines running. So when you are doing this, when you are trying to create this EC2, this one, try to add the host name also to that dynamically, so that when you see this page, right, when you see this page, instead of green color, you will see with the host name. So you know it is going to all 3 different machines, right? So that way, like, you will be sure. So this connection draining will be happening for few minutes. Once that is done, it will start terminating all your machines. Okay, so this is your auto scaling and how it works. Once that auto scaling is completely deleted, then please go ahead and delete your launch configuration. Don't delete the launch configuration while the auto scaling group is still there. Okay, so that's just a cleanup you need to be aware of. Any questions here, guys? And I just need one favor from you all. I want you to go to the drive and please download, because I'm already running short of space. I don't want to pay to get the space. So please go ahead and download that whatever that is already there. and I will let you know which one I will be trying to delete, so that you guys are aware. I will be deleting this cloud fundamentals, okay, introduction, and these both I will be deleting for now. Okay, only if I delete these two, I will be able to upload the new one today. But I would recommend you all to go, please download the other things so that I can go delete it after tomorrow's class, right? Just a request, please do that. And if I delete it from here, I will not have the recording back. So please download it, okay? Please download it. Just hold on, I think this will take 5 minutes for you. So don't worry, I will go and do the cleanup. After this is cleaned up, please delete all your machines here. Delete your security load balancer. Delete your target group. That's all. Then we are done. Okay. Any questions that you guys have? Anyone? So we are done with EC2 completely. So if you go back to the EC2 console, we would have seen right from the start on the above till the last. So we are done, and tomorrow we will be starting with simple storage service, which is called S3, right? We will talk about that storage service. Okay, that's also one of the key important service. So we will talk about that service. Any questions for today, guys? Anyone?
No, Chandra, we'll have to go back to that recording and we'll try to do.
Yeah. Okay. All right, guys. So we will meet tomorrow at 7 a.m. in the same link. Okay, I will share the details once it is all uploaded. I will put it in the WhatsApp. Please download it, and I will be deleting the introduction and the cloud fundamentals for today before I upload this. So if you haven't uploaded, if you haven't downloaded, please download those videos. Okay. Yeah. Please practice. Whatever I'm saying, it will look as if it's very easy, but as you start doing only, you will get a lot of questions, and you will get some lot of answers by searching for those questions. Okay. All right, guys. Thank you and have a great day, and we will meet tomorrow. Okay.
Thanks, Chandra. Thanks.
Yeah. Thank you.
Yeah.